Rockets, propelled with engineering and chemistry, and more than 2 millennia of research and invention, have passed great boundaries of discoveries and innovations leading to modern-day space travel, but rocketry made its noble origins from a mechanical bird and a simple heating machine. We will explore further into the origins of this science with this book. Now.
In ancient Greece, there was the poet Lucian. He tells of a ship lifted into the air by a great storm and carried to the shining island of the moon. But, said Lucian, these were things which were not and never could have been. And for 1,000 years thereafter, the men of science agreed. Everyone knew the Earth was the only world and center of the universe.
The principle behind rocket propulsion was employed in a steam engine invented by Hero of Alexandria. The copper vessel, which was heated by a fire below, represents combustion in rocket engines, while the rotation of the steam vessel represents liftoff for grand spaceships. Meanwhile, the Chinese of the Song dynasty developed an arrow powered by gunpowder to dazzle and strike at the enemy. By constricting the opening at the back of the arrow for higher pressure, they increased the range of the fireworks to nearly 1 kilometer. The classic science fiction writer Jules Verne brought the dream of traveling through space to life. In his story, he uses a giant cannon to fire a manned projectile to the moon. In reality, a cannonball traveling away from Earth at a speed greater than 40,270 kilometers per hour will eventually escape Earth's gravity, slow down, and then stay in orbit. While this cannon was nearly impossible, Congreve, an English inventor, came up with another idea: incendiary rockets for the use of destroying faraway ships or buildings, such as Fort McHenry. In his masterwork entitled Isaac Newton stated his laws of motion: at
rest remain at rest, and objects in motion remain in motion in a straight line, unless acted upon by an unbalanced force. Force equals mass times acceleration. For every action there is an equal and opposite reaction.
Russian scientist Konstantin Tsiolkovsky, who wrote and taught about human space travel, called for liquid propellant rocket engines, and created a rocket equation based on Newton's second law of motion. Applied to rocketry, his law meant that the more propellant a rocket consumes at any moment and the greater the acceleration of the combustion products going out of the nozzle, the greater the thrust. The rocket will also gain speed over time as the inertia and acceleration accumulates and the mass of the vehicle lessens.
Yet there is a point at which the rocket principle became a practical consideration as the means of investigating matters beyond Earth. In 1926, Dr. Robert H. Goddard, an American college professor, successfully demonstrated the fundamentals of controlled rocket flight. His theories, still valid, shaped first outlines of a now dynamic and vital area of science, rocket technology.
Many more creations followed.
Rocket rail cars, rockets for ice boats,
This
rockets
new
for gliders.
creativity inspired the German Wernher von Braun to become father of rocket science. But in 1939, an influential dictator took the right to war in an attempt to take over the world and prove the dominance of the so-called Aryan race. Hitler gave great funding to a program for building and launching a vengeance weapon to use to strike at his enemies, the Allies. That, after many costly failed attempts, killed 5,000 men in London until Penament, the site of the missile launches, was bombarded by and destroyed by the Allied troops. This V-2 rocket was propelled by water, alcohol, and liquid oxygen carried in large tanks. It had gyroscopes and cooling systems. But these products, produced from the hard work of prisoners of war, were significant to human achievement as we know it today. The huge tanks are made to accommodate tons of rocket fuel and oxidizer to propel the rockets. Using Newton's third law of motion, both make up the reaction mass as part of the exhaust fumes. Using rocket as an example, a solid cylinder with propellant forms solid fuel, while kerosene and liquid oxygen, aided by large pumps, make liquid fuel. In turn, a combination can be used in a hybrid rocket. However, these are complex combinations. For example, the Saturn V used rocket propellant compound number 1 as fuel and liquid oxygen as oxidizer. The space shuttle used liquid hydrogen instead as fuel. The combustion chamber, throttle and nozzle make up a rocket engine. The fuel and oxidizer reacts in the chamber at high pressure to be expelled out of the nozzle in low pressure. The throttle allows thrust, which makes the rocket react by lifting off into space. A great mass of propellant is needed because a spaceship like this weighs 72,842 kilograms. However, with the 754 tons of the external tank and 582 tons of the solid boosters, the whole space shuttle weighs nearly 2,000 tons. To minimize the cost, rockets are divided into a variety of stages. For example, the Falcon 9 splits into 3 as propellant is used up. Most rockets have several separation points for the multiple stages. Which are often assembled before launch. These great inventions soon saw international competition, and the Soviets pioneered the launch of the first person into space. After this, the US launched Explorer 1 with a satellite of its own. Finally, the US launched Saturn V for the Moon. The shuttles go even farther, as 2 separate boosters fall before orbit. However, this process is not always perfect. This may seem like a normal space shuttle launch. But today is January the 28th, 1986, when after moments of tension, Space Shuttle Challenger exploded 73 seconds after liftoff. One large crack, likely caused by icy weather, created a large gap in one booster rocket, which ignited all of the fuel in a fatal explosion. While space exploration may have advanced the science and technology in the modern world, it has led to many troubles. Notably, rocket fuel is largely volatile and has caused several incidents such as seismic explosions and pollution of water sources with perchlorate. Rocketry can also be employed in missiles to strike and destroy military targets. Nevertheless, the door seems to open to the future of rockets, with private companies, sustainable fuel, efficient stages, and a vast cosmos to be discovered. The purpose of space exploration is to find the answers to our creation. Thank you for watching this presentation.
For the Delta II rocket with Kepler on a search for planets in some way like our own.
Vernier engine chamber pressures are building. Groundlet solid motors are building in chamber pressure.